Matplotlib is a package which is basically used mostly in the your graphings, like for the 2D plottings, 3D plottings, and like those, right? So for plotting, we have mainly two type of things, like for Matplotlib, and the other one is called as Seaborn. Okay, so Seaborn is like you can say an advanced version of this Matplotlib. How we can just you can say to give some stylings or to get some more generic data of you want to get some more plottings of generic data, so you can use Seaborn there in case. Okay, so this is Matplotlib, and you have to import this as PLT. Okay, so Matplotlib as PLT because you'll be now instead of writing the pipplot and all those, I'll be only writing PLT. That is like a short form, you can say. Okay, a short form one. So so we'll be having some data, and that would be used to plot on, right? We'll be using it to plot on somewhere. Okay, so let's say this is my x and this is okay. This is x having some of the data. Similarly, let's say this is y and this is okay. This is 2, 4, 6, 8, and 10. Now, if I want to plot this x and y, what would be a graph? A straight line you will be getting, right? Like y equals to mx plus c, where you'll be having some values, right? So, for plotting this, you will have to write plt dot plot. That's it. Give the parenthesis, and you want to plot x and y. That's it. Okay. So, in the x, you will be having x values, and in the right, or you can say in the y side, you will be in the y axis, you will be having y values, right? That is 2, 3, 4, 5, 6. You can see the things. And here, right? So this is like a kind of thing how you just plotted the data, that is x and y. Now to feed this data a more generic term, what we'll do, we'll plot x and y. Now this is particularly called as like, and say it is called as giving x label, y label, title, changing color of line, and also the style, the width of line. Okay, so now we'll see a lot of things only in one code. Okay, we'll give some labels to this x-axis, we'll give some label to this y-axis, then we'll give a title to this, we'll change the line color, also the line width and the line style too. Okay, so we'll try to do all those things, right? So this we have to just plot this x and y. Okay, and now if I say that the color, if I'm talking about the color, so for changing the color of the line, you will have to specify something in the strings, right? So let's say you are specifying red, R. R stands for red, right? For the black, it will be K, and there are several color codes actually. So let's say this to be a red line, right? Then, if you want to give like the if you want to change the width of the line, you will have to write it as line width. And that you can define like 2, 3, 4, something, whatever you want. Let's say to be 4. And then we are writing line style. So line style are some of kind of types that you say to be dash or dash dash or dotted or like that, dash dot or triangles, anything what you want, right? So I'm taking as dash dash. Okay, so that is also termed as dashed or dotted or dash dot or triangles, circles, a lot of things are there, right? So we are trying to draw a line, a red line whose width will be 4 and the line style will be dashed up, right? And after that, before plotting this, will give the x label. That will be the x-axis label. So x is some numbers, or you can say is x is numbers. That's it, right? So these are numbers. What about y? What are y? Y is 2 multiplied by the numbers, right? Y value is the 2 multiplied by the numbers. And what is the title? So what should be the title of this graph? So I can write it as double graph, right? And then you can just, and every time just use this code, that is plt dot show. So show the plot. Okay. Okay. So we'll run this, and you can see just a plotting there with the x label as numbers, y label as 2 multiplied by numbers, the graph titled as the double graph, and then the line to be read, and also the width to be enlarged from the previously one. Okay. Now also, let's say if you copy this code, now let's say that if you are saying, if you are taking it as like O, okay, O. So what will happen? So you can see something over here, and that is like if you see in very good insight, with a very good insight, what you will see that there are some circles like one here, two, three, four, five. Okay, there are some circles over there. Those circles are nothing but the x and y coordinates. Okay, like here we are not having, here we have written r. So that are not exactly the correct ones to identify. If we write GO, then it would be probably a green one. But it is merged with the line, and the like the circles are merged with the lines and all those things, right? So to like give some other colors to this circle, what you will do? You will remove this. Let it be red. You will again plot this x and y, but now you will be plotting with green colors, green circles. Okay. So now this time when you will run this, one error is there. Okay. So x and y with. Okay, let's change the marker edge color. So let's say it to be red. So you can see the marker edge color to be red, right? And like the things has been changed on, right? So this is how you can like uh, make separatable things, right? You can even change the marker size, right? So you can even change the things. It's looking like a small one here. You can change it on, right? Mm. Okay. So this you can do with the help of like matplotlib. You can plot these things, right? Basically, I'm giving you just an idea of how you can just show your plottings, right? So to see a better visualization with this, you use something called as Seaborn, right? So let's say we'll plot this data. Okay, let's say this is height. Okay, so let's say these are some of the height I've taken. So let's say some weight. Okay, so this is like height and weight. There we have written some 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think it's written there. Okay. Now we'll plot a graph according to this. Okay. And we want to find actually BMI. Okay. So there is one formula for finding it, but we are just plotting the data of height versus the width, right? So in the X level, I'll write these are height in the centimeters. And here we'll write these are the weight in the kgs. Okay, so like this, let's just plot it there. So you can see like a graph there, which is like height versus weight you are getting over there, right? But that is not very clear to find on the things, right? That is not very much clear. Like 120, you're having, if even if you write it as, let's say you're plotting this as yellow dots. So you can see now this is looking much better as compared to your lines, right? That is, a person having 120 is having a weight around in 50 to 60, for like 140 or 152 or 156 height would be having some range of this one. Okay, so you're getting some things over here, like you're having some good points you can see on it. Let's say to be red points or green points. Okay, so like these are the points you can see on. Okay, but if I say that we want to plot a histogram and run this. Now let's go with the bar first. So with the bar, what you can see, like you are having a data, and that is height in centimeters, weight in. There you are getting some points 1, 2, 3, 4, 5, 6, 7, 8, and some points are there, right? So you can get plottings and all these things, like okay. So to get a very good understanding in the plotting section, we use Seaborn like of things, right? So there actually you just write it as import Seaborn as SNS, right? And you can do a lot of things with the Seaborn if you like. You can pass on this SNS dot. So this is just an idea what I am giving you. So let's say you want to plot x and y. Now x and y is like you want to plot height and weight. Let's say. not interpret h is small, h is smaller over there. So you can pass on small h and then you can, okay, it's not taking there. So there are options like this is height, okay. So like you're having a height and they are finding 154 for 2, 165 to what are these actually is nothing but you are having some same height what are you getting. So what are the common height are 154, 65 and 87. We are getting two heights like in that case, okay. What about the weight? If you want to see the weight, is there any weight same? So you'll get no, none of the weight are same, right? So if we just want to compare these things, we just want to let's see a graph of more intellectual things, or if you say this here. So there actually you count the things, okay? There you actually count. So you can't pass x and y to that, okay? So for passing x and y, okay, let's first remove from here. Let's copy the data. Okay, so you can't just take on the data from here. So to passing on the x and y, we have some different kind. There are a lot of plottings actually in the Seaborn. I'll show you. So here you plot the scatter plot between the x and the y, okay, and like this you are getting the same data what you got from here, right? What you got, and even you can enlarge your data accordingly, okay. Even if you want to give it an like enlargement, you can also provide that, okay. So you can see the scatter plot. Meanwhile same, so you can also find the box plottings here. You'll be getting like moreover the one value or this box what you are seeing is having some two values, right? That is you are seeing 1 and 2. So this is 1 2 3 4 5 6 7 8 9 and 10 inputs, right? This one particular line states that this is only one age over here and one value with that, right? This two states that these are the two different or you can say the two weights or heights are there, right? So this is like you get plotting. Even there is one called as swarm plot. So there you get some colorful plottings actually, okay, according to your data. So this is like how plotting works on, okay. So you collect the things from your data and then you plot out the things there, right? So we'll be learning the data structures today at our last topic, and we will be giving our examinations tomorrow, as I said. Okay. So like first is like your pandas. Okay. So this is the very first thing to learn data structures, right? So here you have two different kind of things. One is called as series, and what you will be learning is the series and data frame, right? Series are what we learn in the NumPy. Series are 1D array, and this data frame are two dimensions, right? You can say 2D. It will be a collection of rows and columns. Okay. All right. So let's say for series, for creating any kind of series, you will have to write pd dot series, and then you pass on your data like what you want, what series you want. Okay. So let's say you are saying I want a series of 1, 2, 3, 4, 5. So whenever you run this or whenever you print your x, you will see this to be 1, 2, 3, 4, 5, the data types there, and also the index numbers there, right? These 0 to 4 are nothing but the index numbers of this 1 to 5, whatever you're getting there, right? This is an integer of 64. That means that every individual will be having an item size of 8 bytes, right? So like you can create a series with that, right? This is a series. Even a series is having a name, right? So every series have a name actually. So this is not having anything, but we'll go with the thing of data frame. There will be making a column as a series, and there we can see like it is having a name over there, right? So there we can find it similar to that. Okay. So this is like the first series you have it, right? A series can be made from a different type, like for the dictionaries, the tuples, and a lot, right? So like you can just in the data, and even you can make what I said like yesterday we did for the marks and all, right? So let's say this is mathematics, and let's say the score is 90. Let's say this is science, and the score is 87. Okay, so you're creating actually a series of some dictionaries, right? So you're getting mathematics 90, science 87, and so on, right? So this is like how you can create a series, how you can manipulate the things there. Okay, right. So a series can be created with a lot of things. So you have seen how we can create a series with list. Now you have seen how you can create a series with a dictionary. Even you can create a series with the numpy array, the the tuples and like that. Okay, so let's create a series with the numpy array. Yeah, and always now here you have noticed, if you have noticed, right, you are not getting any index numbers as 0 1 2 3, right? Because I have said you that when like when you are learning dictionary, that these things, these dictionaries are always indexed using their own keys, right? So these are the keys and these are the index values of these things, right? So let's make a series with numpy array. So we'll have to import numpy. Now writing data is equals to is an optional method. If you want, you can write. If you don't want, it's not like necessary to write. Okay. Cool. So let's say this to be an array, and let's say this is 1 2 3 4 5 6 7 8 9. Okay. So just making a sense of arrays, right? So you want to arrays, and just you run this, and there is some error. Okay, here is an error. Okay, fine. So you can see a series of like 1 to 9 numbers with having some index numbers, right? And the good thing is that you can also change the your index numbers if you want it not to be printed from 1 or anything else. You can change it. Let's say this time you want only the 3 numbers, okay? And here you are saying that you want your index to be something different, right? Let's say you want A, you want B, you want C. Okay, so this should be your index numbers you are saying. So all right. That to be outside. So you'll see that this is 1 2 3, and you are getting ABC as your index, right? You can even change on the index accordingly with your arrays or like with your numbers what you are getting. Okay, so similarly you can just create an array, or you can create a series. Let's say this is a series of the data which is np dot random dot random of 10. Okay, and this is, let's say this is x1. Similarly we are taking x2. Now x2 will be the pd dot series, and there again took a data of random dot random of, let's say this to be 5. Okay, and let's make it 6. Alright, so these are two of the data. Now if you see your x1, this is like some random numbers what you have studied, right? What is random there? So like you will be getting some random numbers from like 0 to -1 and like that. Okay. So like see, this is your x1, and if you just see on your x2, similarly you will be getting the data of x2, right? So these two are like very similar. Here you are having some 0 to 4 numbers, and here you are having 0 to 5 numbers, right? So if we just add on the things, let's say this is x1, and you can even write this add, and then you can write x2. So this will basically add on x1 and x2, and now you can see some float values as the data type, but in the fifth state you are getting a nan over here. That says that this is not a number, right? Always remember, nan is nothing but not a number. So if you see, like, you are having 1 to 5 numbers here, or you can say this is having 1 2 3 4 5 and 6 numbers, and here you are having only 5 numbers, right? So in the there is no such number in the sixth place, right? So how you can add anything which is not there with something which is there, right? So you are trying actually to add this with something which is not present actually. So you are getting a nan, that is because there is no such values where it could add up these things, right? So you are getting a like value of nan. Okay, understood. So this is like how it works. Now slicing also works well with the things like you say x1 of 2 is to 3 uh, plus the x2 of 3 is to 2, or 1 is to 2. So like you get the nan values actually. Okay. So if you just find on things from here and there, and you just add on the things, you'll be always getting like something that's okay. Fine. So like these are called as your these are actually done with the C. Okay. So something like basic manipulation of the data. Now like let's try to understand the data frames. Now data frames are something which are like a collection of 2D array. What I said, like in the rows and the columns you will be having on, right? So let's say that this is data of a website. Okay. So this is a generic data of a website. Let's say this is Monday, and let's take some real time data. So let's say this is an account info. Okay. So this is some bank ID, and or let's say that there would be some name. Let's say Mr. M.K. Malhotra. Okay. And he's having right. So this is a like you can say a dictionary of Mr. M.K. Malhotra, and you can even make one more dictionary inside that, right? You can say this to be days, right? And there you can just pass on the values like you are having Monday, you are having Tuesday, and you are taking Wednesday. Only 3 days, right? So in Mr. M.K. Malhotra, there will be a dictionary, there will be a key called as days, where you will be having Monday, Tuesday, and Wednesday, right? And then you say that you're having money, or like uh, you can say balance. Okay, balance. Let's say it would be good, right? If we say balance, that would sound nice. Okay. So let's say this is balance, right? And now let's write some numbers over there. So this was the balance in the Monday. Let's say this balance to be not give drastic change. So this is the balance on Tuesday. And this is the balance, let's say, on Wednesday. Okay. So you like generated something as your a dictionary kind. Okay, you have just generated a dictionary itself, right? And like if you see your account info, if you just see the account info keys, so that would be, oh, you are having MK Malhotra as your keys, right? And even if you just go like for the account info and then you pass on like the MK Malhotra itself, Mr. MK Malhotra. So now if you pass on this and you see the keys, you'll be getting days and balance there, right? That is like whatever the days and balance. Now data frame is something which will combine these values in rows and columns. Okay, so if we say that we want a data frame of this account info, so you can see like on this this is having one particular your name and you are having balance and days, but this is not looking well in a well mannered like way, right? So what you can do is you can just give a comma there and write this as like this. So you can pass on like names, okay, or you can pass on the customer, you can write an CUST, okay. So you can write that these are your customers and you are having their balance, right? So like this is for like MK Malhotra. Next take to be Mrs. Smita Daniel. Okay. Next take to be like Mr. Pavan Kala. Alright. Just take some random things and give just a comma over there. Just to be removed. Okay. So now your keys are like what happens? Okay. So now your keys are customer data, that is like customer data, the days and their balances, right? Now if you see the data frame, you will see like this is your customer name, these are the days, and these are the balance they are having. So this you can say this customer, this MK Malhotra on Monday was having this balance, on this Smita Daniel on Tuesday was having this, and like you can see just you can say generic data of what we have generated, right? So you can see like good data, right? You can make it according to you. So just take it according to the student names, their subjects and their marks, right? You can make it like that. Okay, you can even make this to be subjects, and there you can just write down the subjects, or you can give the individual subject names and you can find out, you can name the different students, right? What I'm saying is like you can just say this to be data frame, and let's say here you actually creating a data which is a dictionary, and there as I said you write the subjects as your, you write it as the keys which will be your, and then basically your columns, okay. So like here you have created, so let's take, okay, first let's take it to be, first let's take it as to be names, okay. There you can pass on several names. Let's say this to be Mike, this to be Gary, and also let's say this to be Chris. Okay, so this is like just a data of 3 students I'm taking on, and you can pass on like in the maths subject what are the like marks they have got. So one has got 76, 45, and like 90. Okay, and we can pass it like science and the science, let's do it 98, 67, 35. Okay, understood. Similarly with, let's say, English. Hmm? So in English, like for 65, 87, 89. Okay, so like this, yeah, you can make out the data, and this will generate a data frame with some names, the maths marks, the science marks, and the English marks, right? So you can generate like a good data with that, right? You're having some three names over there, and then you are just calculating out the things from this, right? Now, if you want to see what operations you can see with the data frames, I'm giving you a basic knowledge on that. So now, let's say if you want to see that which student has got the maximum number of marks in mathematics, right? So, which student has got the maximum number of marks in mathematics? If we want to find out, now it is like only a three data you're having, only a three rows and some three, four columns actually. So you want to iterate the things from there, right? So you can just pass on some formulas, you can say, or like you can say, these are some of the techniques what you apply there to find out the things. Okay. So okay, fine. So say you actually want some statistical data here, right? You want some statistical data here actually. So you can name it as, let's say, X, and you can just say to this. Okay. Now for getting a maximum value, you can't just write on X dot max and that like so. So if you see like so, it would be like in mathematics you have a maximum value of 90, and that is like for the mic. For in the English you are having in the science you are having a maximum marks of 98, and in English it's 89. So if you go with this, what do you find? Like the maths is 90, right? So 90 is for Chris, okay. Science 98 is for Mike, okay. And the English, the maximum is 89, and that is for also Chris, okay. So, but in the names you are getting the Mike as the maximum, you can say, like, understood? Why? Because it's like according to your ASCII codes, you can say, right? So every particular column maximum value you have got, right? The 90, 89, and like these things, right? You can also write it as X dot value counts. So it will find the value actually. Okay. So there's one value counts X. So what you can do is you can make a series and then you can pass on for the value counts of what you want. Okay, like say you can say it as let's say this is your X and you want the mathematics, and the maths you want the value counts. Okay, so mathematics value count would be like for 90 it's 1, 41, 76 1. Now this means that there are three data, right? And among the three data, only one student has scored 90, one has scored 45, and one has scored 76. Like for the several, you can make it on like that. Okay. So you can get a graphical plotting between these things like math, science, English, and names, right? You can find out between the maths and science. Now let's say you can use this Seaborn plotting, as you can say. You can use this scatter plot actually. Mhm. So you can say this your X you want to pass on is mathematics. You want to see a graph between the maths and the science, and the data is X. So it will just create a plot using these things. Okay, you will just get a plot with some data over there. Okay, you can add on the data to get a good graph there. And there is one add-on. You can use this hue semantic, or this is called as basically labels. So you can use this hue semantic, and I am saying this to be given as names. So to get a generic data. So I am getting like this green stands for carry. Oh, sorry, this Chris. Chris has scored in the mathematics. He has scored 90, and in science it would be around 40. What is the value? Okay, right. It's 35, not around 40. It's below 40. Okay, so it's 35 over there. Gary has scored in mathematics. It would be around or less than 40 or 42, greater than 40, I think. Right. So it would be, let it be anything. And like in the science, he has scored about 60. Like you can see the graph actually. What you can use the scatter plot. You can use the swarm plot. You can use things and you'll be getting, like you can use the box plot. There are rel plot and a lot of things are there, right? So you can see like individual values will be having individual colors and like that, right? You can even use the line plot. Now the line plot will like give you an error of this. So line plot will not give anything because there is no such generic data. There are not a lot of data to just plot the things, right? So you have here like a violin plot. Okay, so that will work only if you have a good data. Okay. This plot is. So just let's take a scatter plot of that. Okay, not going much in this plottings, otherwise you will have. Okay, so like you can maintain these things, right? So data frame actually makes a collection of something which is which will have around 2D things, right? Which will have a column or a rows of things, right? So let's take a data frame now to read any file in your Python, in your uh, Jupyter notebook. To read any kind of file, you will have to pass on a function called as read underscore whatever the file format you are having. Okay. So let's say we are reading in PD, that is read, or let's say to bring something from the net. Okay. So we are taking SNS dot load data set, and let's say we want to load the iris data. Okay, so that is like X. You will be having a lot of contents here, and you can see this X is nothing but some data over there with some species, petal width, petal length, sepal width, and a lot of things are there to see, right? So you can see something over there with the X. So what you do is you just write on this SNS dot load dataset. This will automatically load the dataset from this is automatically load the dataset from this iris and this platform of the SNS, right? Seaborn, you can say. So in Seaborn, you have a lot of dataset for free, which we can use for like modelings and machine learning and data science fields. Okay, so we use those things there. So like you are having species, petal within, like these are the things over there. Okay. So to find like or to see a graph between, we can see like there are setosa, there are virginica. So for the first time, whenever you load your data, your first work is to get the information for that data. So there you have function like the data name and press the info. So you'll be getting the information, that is it's saying that it is having a range index of 150 entries starting from 0 to 149. The column names are sepal length, sepal width, petal length, and petal width, and you are having species with some non-null counts over there, and the float and the objects. Object states that this is having a string actually, okay, other than the complex integer and float, right? Now, if your data is having any null values, you can get it from like so if any null values are there, you can just see a plotting of that, right? So we'll see null one in the next data set. Okay. So this is like exactly you can say quick info or like information of your data what you want, right? So you have species 150 over there, right? 150 species are there, and like in the numpy you have seen that if you want to find actually this iris is a flower. Okay, it is having exactly 3 species, not 150 species. 150 species are there because these have been repeated on. Okay, these have been repeated on, and like for that you are getting uh, those species. Okay, so if you want to see like what are the exact species of this your you can say this iris data set. So for the exact species, what you will say that you want to find in the X, you want to see the species. So it's saying that this is species, okay. The series name is species. It is having 150 species and the data type object. But we know that this is not 150. So what we'll say, we want only the unique ones. So the unique are only the Setosa, versicolor and virginica. Okay. So that is only three kind of species are there, what you can see, right? The data types and only the three kind of species which we are having. Now to find out, like now we know that there are three species and these are divided in some 150 parts. Okay. So what are the exact ratio of the things to count on for that? So for that you can just see with the help of the graph, that would be much better. PLOT and this is T, count plot of X equals to species, the data you give X. So it will give you a count plot actually. So this will take some similar data from there and then we'll make a count of that. So you can see like Setosa, versicolor and virginica, each three of them are having a count of 50. Okay, that's why this 50 multiplied by 3, you are getting a data of 150 species. Understood? So this is just a data like what you are getting and like how you can make count, how you can count on the things and let's make it. Okay, fine. So we'll see something next to it. Okay. So now let's say now it might arise a question, right? How many kind if you are having this species? So if you want to see like the graph value or like a graph what are the difference between a sepal width and sepal length? What are the graph actually of the graph of the things? Or among these three, okay. So among these three, what is the exact, or you can say like among the Setosa, virginica, and versicolor, which is one of the species which is very different from all these? Okay, exactly right, because there are some three kind of species with this iris, right? So which of the species is very different from all of them, right? Which is a species, what are the differentiation, or you can say like the difference between these species, right? So you actually see a graph of that, right? So you can plot any graph between any of the petal length, sepal length, width and all those, right? You can just say that we want to see a swarm plot of the data and let's say we want to see petal length and it will be petal width. So let's take any of the things, right? And you can give the hue semantic as species, and you can say your data to be X. So you'll see a graph there, and let's wait for some moment. Still any spelling mistakes. So yeah, guys, you can see a graph there actually with some of the petal lengths and widths there, right? The 50 petal widths and the 50 petal lengths you can see. Okay, so that is like what the things you are having on. Nice. Okay, so 150 data and currently are having the things right there. Okay, that is from here we can find out that Setosa is like easily very different among this versicolor and virginica. However, there are some same for some of the times. Let's say if we compare with this sepal length versus the petal length. Okay, and we want to see some scatter plot of that. So here we can just see on that this is like separated again. So every time when you will like do some operations on this plottings according to your data, you will see like these are actually separated from this whole three kinds, setosa, versicolor and virginica. The setosa category is always separatable, okay, always. So even if you just find a violent plot of this, you can find like this is again separatable, okay. So here if you just zoom on, you will find some green colors. This is like red and this is blue, this is green, and these are blue actually, but you are not able to see these things. So what you can do, you can just make it big. So for that you will have to write this as figure, this to be figure, and in the fixed size to be, let's say, 20 cross 10, or let's say this 10 cross 20. Let's run this. A bit big size will come. That is not good. Yeah, that's nice. You can say, right, because here you can see a lot of data with that. So if we just zoom on the things, we can find a violent plot there. So if something is having a range of values, you will be getting a violent plot there. If it is not, if it is a single one, then you will be getting a dot there, right? So you can just see the differences between the things, and there we can classify that this category of setosa, the species of setosa, is very different from this your virginica and versicolor. Okay, right? This is very different from that. You can like see it how it is. Okay, that's nice. And we use these things in the machine learning actually. So that is not of your course. Okay, fine. So like you can generate the data. Now coming to the next data type, let's talk about something different. So let's take this X again and load some different data over here. So let's load this Titanic data now. So this is X. Now if I just print on my X, I could see a lot of things starting from 0 to this, right? Now to find out, see guys, now to find out some exact values, or you can say some to find out starting values only. If you want to see only the starting values, you will have to pass on this head here, right? That is head, okay. Now using this head, you can see on the first 5 rows of your data frame, or you can say your data. So first 5 rows of your data is 0 to 4, right? Then similarly, the tail will give you the last 5 rows of the sorry, not all. Let's say so. This will give you the last 5 ones. So what the information we can get from here, that we will be having some 890 passengers. Okay, so passengers would be the total number of the rows we are having would be the number of passengers we are having. Okay, so like we are having survived, class, sex, age, siblings, Parch is nothing but parents and children. This is sibling and spouses, the fare, embarked, class, and these are some unwanted things, like because it has mentioned S. S stands for Southampton, C for Cherbourg, and Q for Queenstown. So it's not of any use like for writing it for 2 times and alive again. So survive of 0 stands for this is not alive. Alone stands for true only if like this sibling and parents children are 0. So only if both of the columns are 0, then we can say that this was alone, or this was like leaving alone, right? It was just traveling alone. He or she was not having any particular thing, right? So that says like, so these are not of any use actually. We'll later on but drop. I'll make you see how you can drop your data and like that. Okay, fine. So this is like tail. This is an head. Okay. Now to get a statistical output of your data, you can pass on a function called as describe, and there you can better find out the things as like the standard deviation, minimum 25%, 50%, maximum value 75%, count, mean, and a lot of things according. So only for those columns which are having a float or an integer value. Understood? So that will be only for that. Fine. Okay. Now we'll operate some questions. Okay. We'll do some questions from this data frame. Okay. Now let's say you are asked to find on how many people survived in this Titanic data set, right? This is a data set of how many people survived in that ship. Okay. So like if you want to see the you can say graph of how many people survived. Hmm. So that will be like just a graph of how many people survive. So that will be just a count plot. So this will not give you an exact data. For exact data, you have to work on some codes. Okay. So like let's say a count plot of you say this to be survive. Okay, and the data is X. So we can see like the survived are only 300 plus survived and 500 plus not survived. Among this 800, 800 or oh yeah, among this 890, 300 plus survived and 500 plus not survived. That's bad ratio actually. So what is the exact number of people who survive? So exact number of people who survive will be the ones, right? That will be the ones in the survived column. So if we just find on like what is the survived, what is the survived values? So you're getting some 891 results with some 0 and 1. So we need only to find out where are the 1. So you are getting some true and false results now, right? So you want to count on like the number of what the number of true will be there, only that number of student sorry, only that number of passengers would be survived. Okay, so let's say this to be a list and we want to count it true. So we could see like 342 as the number of passengers who survived on this data set, right? According to this data set. So the non-survived will be around, like you can subtract and also get 890 minus this you can subtract, and also like you can get it 549 as the ratio or something which has not survived. So if you see the ratio, cool, 1.60, 1.6, bad. Okay, so this was like the oh sorry, 549. H2 you can perform it as 890. Whoa. So the deviation would be coming as a very bad. Okay, that's nice. Fine. So like you have seen the number of people survived and like that. Okay, that's nice. Now again get back to your things. Now we'll see how many males and how many females traveled on. Okay. So again for that you can find count plot, and also you can just say like in the X, I'll just giving you a data like how you can use things. So this is the 6th column and you can just say this to be value counts. So you can see like 577 males uh, traveled and 314 females traveled. Okay, like that. So how many males survived and how many females survived if you want to see. So that was a total survival, right? So but how many male and how many female survived if you want to find that thing. So how you'll see that, right? So for writing a code, you'll need some good habit, right, of and or things. But in the case of seeing a graph, that is again easy thing. So you basically want to see the survival. You want to see the survived on the basis of their sex, right? And the data is to be from the X. So there is one SURVI, okay, spelling error, VED. So like you can see one, which is the survival. So we can find like around 100, 110 or 105 male survived, and around 200 plus female survive, right? Like exactly the doubles. But in not survive case, this is exactly the opposite, right? There the males are the larger who didn't survive, and the females like very less data of how they have survived, right? Even if you want to see this data, so every time it changes according to your view, right? So this is like good one, right? Now you can see, like you can also plot it, or sorry, you can also count this thing, right? For the survival, what you will do, you'll make a list where you will find out that in this X of this X column, where it is male, okay, and in this X of survive, where this is 1. So only in the places where this X comes as male and this X comes as 1, I'll be counting the true numbers. So there is some errors. Alright. So the truth value of a series could not be taken. Okay. So truth value versus ambitious, empty boolean, find things and so take a list of this true elements. Hmm? Take account of this and then converge it with this X, another one. So let's see this. 342. It's the total number it's giving. Okay.
money.
X of this X equals to male and this X of survived equals 1 dot count of truth values ambitious is an empty and boolean item anything at all. Okay. Fine. Okay. Let's wait for 2 minutes. Needs to be the faces. Alright, so let's take it first as male and count the values of true. Five 77 are male. Okay. And among this, how many have survived? We will have to see that. So it's giving some ambitious data there. Okay. Nice. So ambitious data. Let's say if we pass on this and if we check this as okay, let's not take this list. Just say this where this x is equals as male and let's take this where this x is, I hope this will work, survived and equals to 1. So nice. So this worked. So there are 109 men's. Okay. So 109 men's are there who only survive according to this data, and that's generic, right? We can see it from there. So like this is on the basis of the sex and the survival. 109 survived. According to this, I'm getting yeah. So yeah, 100 and like survived over there. The orange stand for 1, so that's 109 survived, and some like non-survived are more than that, right? If you see the more not survived, so that will be around 468, and if you add 468 plus 109, you will get 577. The total men what we actually find here, right? So that's nice, 109 there, right? So for the females, you want to see, so you can also see the females over there, like for the 0, not for the 0, for the 1. That is exactly double than that, right? The survival is exactly the double, right? So how many survive? No, because the class also matters, right? So on the basis of the class also they have survived. So if you see a count plot of that, if you say you want to see the survive, and on the basis of this, or you want to see the survive, let's say on the basis of the class, I think it's P class, if I'm not wrong, it's P class, yeah. So this is P class and the data is your X. So you can find that the passenger who were in the first class were mostly survived. Okay, mostly survived, and like the third class people or the passengers who are in the third class has mostly not survived, right? From this data you can see. So you can also even find out things like how many people in the third class actually survived, right? How many men in the third class actually survived? How many like males survived in the third class? Okay, so total survival in the third class was for the total survival, let's say, so the total survival in third class would be like you want to see the survived. Okay, and here you want 1, and you also want to see the P class to be 3. Okay, and you want a list of these things. And you want to see like how many, so 119 are there in the third class who survived according to this data, right? So you can see like in the third class this much people survived. Now what was the number or what was the ratio of the men and the female who survived in the third class? Because third class was also having the both the sex, right, for the male and the female. So what is the ratio of the male who survived in this third class? So for the ratio of that, you'll have to make some only changes here, right? Only some changes. So you will pass one more and here, and you will say like there you also want to see like the sex equals male. So only 47 males survived from the third class. So what this data according to this female. So if it is like 119 survived in the third class, 47 are the male, then the female would be obviously your 72. Like again, it's a good ratio over there, right? For the females, right? Because the females were saved more, right? According to their ages also, right? So like that. So we also have the age. We also have their ages, right? We also have the age over here. One where it is, yeah, here. So age are there. Okay. You can even find like what were the ages of the people who traveled in the ship, right? So you can find just let's say ages. Uh, oh shit, 6. Ages, it's not there. My age could not input p plus gap. Hmm. So bar plot will come, and that's exactly a bad one, right? So that's a bad one. Hmm. So, hmm, okay, 30. Alright. Okay, let's just plot this as a count plot. Okay, and according to the class, so if we just see on this graph, okay, just see the data of this graph. Even if we just make it large, let's say plt dot figure. So this is having a lot of data actually. So fixed size it's equals to this would be 50. That would be much feasible, I think. Okay, fine. So you can see just the data is there with some plottings actually, and it's looking fine. Okay, so you're having P class, the blue for 1, orange to 1, red, green as 3. So you can find most of the times the green because the number of peoples actually the number of peoples were more in the third class because they were the itself the one who was maintaining the ship, right? So they were only maintaining the process what were going in the ship. So they were most of from the third class, and you can find the ages accordingly. So like the max count is 20. So this is of so like 22 is the ratio you can say 22 is the uh, maximum number of people was the age between the 22, right? So you can also just see a generic graph that is like a description graph you what you are seeing in the above one. You can just see only a descriptive graph of this. So you want to find the age and the data is X. That's it. So you'll see some ages over there. Okay. So the maximum age, if you again find the same, we have this plotted over here, and you can see that, right? So you can plot the histogram of that, and then you can see it. Okay. So we have plotted it according to the classes. Okay. So we can find the maximum ages to be around again, that is 24. Okay, so 24, 25 is the maximum number of ages we are having on. Okay, fine. So like this, you can draw it from there. Okay. Now the next thing. Okay, we have got to see like how many people survived, how many people from which class survived, how many male female were there, how many like what is the average age among these things. Okay, so for getting an average age or for getting an age actually data, so you can also find out this with the age, and then you can just pass on value counts. From there you will get some data over there like this 24, the value is 30, the 22 it's 27, and also you can find the value greater than 1. So how many values are there the greater than 1 if you find out for that? So apart from the unique one, how many are there? So we'll use count and attribute levels. Okay, list has been formatted to applied. 72 are the one which are greater than 1. Okay, that is like which are not common. Okay, so like equals to 1, how many ages are there? Okay, 16, some ages are there which are very common. Okay, which are not common actually. Okay, so those are unique ones. Okay, so like that. So x value counts are something like 0.52 is also there. Okay, so 24. Sorry, one second. So like 24, 30 age for 24 and like the 0.42. Some values are there, right, for the ages and all. Like you can see the maximum number of age from there. So the max age you are seeing from this ages is to be like 30. It's not exactly correct because you're having also an 80 ages over there, right? So there is some issue actually. Let's see. 80, 24 age. What is this age is having? Okay. That's nice. So 80 is the maximum age, right? That is the maximum age at which a person was traveling there, right? So you can find, right, how many 80.0 were there? How many people were there actually with this 80? Only one was there. Okay. So like that you can count, you can make things right. Nice. So you can plot the age, you can plot the things. Okay. So we have C, right? But also, if you see your data very clearly, you will find that there are some NaN, some things over there, right? Some NaN values. Okay. So how many NaN values are there? So C is null. Yes. Anyone wants to ask anything? Okay. So is null like how many null values are there and the sum of that. So each column is being printed with some like values which states that this age is having 177 null values, this deck is having 688 null values, this embark town is having 2 null values. Okay. So we can also see a graph of that. This is heat map actually. Okay. So you want to see a graph of x dot is null. Okay. And let's give some coloring to this one. So like we can see this deck and age is having a lot of null values. Okay, so to remove the null values you have a function called as drop na. Okay, so you will use this drop na. That's it. Now you see your null objects. So will not have any null objects now because you have dropped all the null values. So null values, if any in any case, if there is some null values in the column or in the let's say in the row, in any case, if there are some null values right there, so that will basically will just remove that column, will remove that row or remove that column. Okay, so we'll get the things like this. Okay, fine, understood. We'll go ahead. Okay. Now you can also see a graph again, like for SNS dot heat map and x dot is null and some error there, capital O. So you can find like now this is a complete. This color belongs to 0. Okay. So it says that now this is a complete zero. There is no null values. Okay, understood. So like this is changed. Okay, and these oranges, there's blues, and a lot of colors are there. These are actually the colors what you want to give to your graphs. Okay, that's nice. Okay, fine. So we have seen now. Now the last things. Now we'll be discussing about the examination in the last 15 minutes. Okay, so we'll complete out the things of your course. Okay, so let's say this is like you have alive alone. I will not go with this because these are same at that. Embark town is having some C, S, and Q. Okay, that is like the number of people who embarked from Southampton, Cherbourg, and the uh, Queenstown, right? So how many values are there for that? That is the column of where it is embark. Okay, so you can directly write this x of embarked, and some error will come. So the number of people who embarked from one like your Southampton is 150, for the Cherbourg is 65, and Queenstown is 2. It's nice. Okay. So how many male embarked from the Southampton? So how you'll check? That is embarked to be Southampton, and male. Count true. So there is some, yeah. Unfunction did not contains a loop of Unicodes. Okay. This is and 62. Fine. So 62 males were there who embarked from the Southampton. Similarly, you can find out for the number of females. The males, you can even just plot the graph between this embarked and the 6. Again, so we can see, right, that the number of male from the Southampton was above 60. That seems to be, we have calculated that 62. Okay, we can calculate for the rest of them. So the Queenstown data is exactly having only 2. So from here we can find that the number of male would be 1 and the female is 1, right? So there are two, so obviously one would be the male and one would be the female. And also we can predict that that particular one would be the, you can say that particular one will be the, it might be someone who will have some spouses or like parents or children, like for a family, you can say, right? For that, okay. So for that, you can find out like this is your data according to what? Okay, let's just see your head of one. If you want to see only one, you can pass on this one. So this is according to the index values. Okay. They are fast on. Okay. Fine. Okay. So we use lock and like the things lock and ILOC for like index locations and the locations. If you are like new to this data, I'll just give you one such code thing. Like if we just write on locate of 5, so key error is there. What are the index values? What are the rows index? So see the index values. Okay, so these are the index values, that is from 1 to like the things you're having 889. That's nice. So see, like guys, these are the data which we have generated after removal of the NaN values. Okay, so if we would have not removed the NaN values, then it might be something different. Okay, so these are your index things, right? So to see the columns, no, these are the things which I would have discussed first. Okay, these are your column names. Okay, and like the shape will tell you how many rows and columns you're having. It is 182 rows and 15 columns. I can find out like you are having 890 rows. From that you got only 182 rows. Why? Because the rest were having some NaN values and that has been deleted. Okay, so that is how you can create plottings, how you can work with the data structures. Okay, so this was all about like what you can do with the pandas. So you can use ILOC, the log, to like bring up the data and to print on a particular thing. Okay, understood? So that you can do with the help of this pandas. Okay, all right. So your whole course class has been finished. Nice. So okay, now I'll give you some information regarding the examination, how you'll be going to get your examination. Okay, let me stop the video.